students, my name is Hariom and this is a small lecture on control system. And our control system is a common subject in electrical and electronics. Let's get started. Now control system, if you the first thing should come, what do you mean by a control system? In control system we'll be studying so many things called as negative feedback, positive feedback, but before gonna proceed we should be knowing that what is a control system. Now let's say that for example there are different kinds of systems are there. We call it as, or we can call it an open loop systems and a closed loop system. Now the open loop system is nothing but where you give some input, let's say x of t, and there's a box, let me call it something, let me call it h of t, and there will be y of t. So it means there's an input, there is something going to happen here. I'm going to call it a transformation. I can say that some transformation, and there will be an output. Now let's say that's in a scaling input. What will happen is, let's say you are giving 2 and this is nothing but it's scaling the input, let's say by a factor of 4. The result will be nothing but 8. So simply the input is getting scaled by 4 times and you are getting an 8. So there is nothing. This kind of system is called as an open loop system. There is another kind of a system is where what happen is some fraction of the output will be traveled back to the input side. Now, in order to understand what do you mean by that, let's say for example refrigerator in our home, you can see that, or I can say AC. It's a very good example. What will happen is nowadays if you see the AC temperature itself, let's say if it is the room is very hot, it will increase the cooling. If the room is too cold, it will try to it will do the vice versa, right? Now how it is doing is nothing but every time what happens is there isn't some temperature, it is reading the input will be nothing but let's say the temperature, okay, and the output will be the cooling. Now what will happen is at one point if the cooling is less, okay, if the cooling is less, what will happen is the response will travel back to the input side and say, okay, just rotate the, increase the cooling or decrease the cooling. The best example which I have studied and I can say that is this can be understood. Let's say that I want to put one pen here, okay, and if I tell you to pick that pen, the immediately your hand will go and you pick the pen. But if I put you blindfolded and I keep pen somewhere else, what you will do? You'll be always looking. You never know that pen is here, there, on. You don't know the place. You have to find that pen, right? So what you will do in that case? You look whether I got the pen. No, I got the pen. No, I got the pen. No. So you get the pen. So every time when you put your hand here, you are giving some response to your system whether I got pen, yes or no. So every time, so this is what is called as a feedback. Every time your hand is giving up a signal to your brain, no, I have not got the pen, I have not got the pen, I have not got the pen, yes, I got the pen. So this is what is called as a feedback. So that the system where we have a feedback from the output is the signal itself is flowing back to the input side, we'll see in a details, and that will be called as a feedback system, or I can say it's a closed loop system. Now there is something called as transfer function. Now basically transfer function is nothing but, if you study in the book, it's called as, you might have studied the whole definition, that is h of t is nothing but or y of t. In signal system you would have studied that y of t is nothing but h of t convolved with x of t. And although it's not a signal system class, so I'm not going to put a focus on there. So basically what I'm dealing is, this is nothing but the output by input in Laplace domain. So what I'm saying is h of s is y of s by x of s, which is nothing but the output in Laplace domain by the input in Laplace domain. Okay, now this is what is called as a transfer function. Let's see that how can I find the transfer function for one of the simple circuit. Let's say that this is a circuit given to me and somebody asked me the transfer function. So I know that a transfer function is nothing but the ratio of output to that of input. In this case, this will be my output. Let me call it V naught of s. This will be the input. Vi of s. Okay. Now, so basically, can I say that if it's nothing but the voltage here to the this voltage? Now, if this is the source or the source voltage, this as per the KVL, the source voltage will be equal to the drop and drop here. So, can I say that? Now, the first thing is that in order to do that, how can I find? So in order to do that, first I have to conclude the impedance of a capacitor. Impedance of capacitor, how can I get the impedance of capacitor? Impedance of capacitor is nothing but it's very easy. I know the basic equation, Q is equal to CV for a capacitor. So dQ by dt or rate of change of charges is nothing but C dV by dt. But if you note it down as per the rule of differentiation, it will be V dC by dt. But as capacitance cannot change with respect to time, this quantity will go to 0. So dQ by dt should be equal to C dV by dt. The rate of change of charge is nothing but your current. So C dV by dt. Now if you are good enough in Laplace, what do you know is the differentiation of Laplace is nothing but, so if I take the Laplace on both sides, it will be C, it will be S, V of S. Now if I do again, V of S by I of S is nothing but, V of S by I of S nothing but 1 by Cs, and voltage by current is nothing but called as an impedance. So this is what my Z of S, I can say that, right? So this is nothing but the impedance of a capacitor, or I can say the impedance offered by a capacitor in terms of Laplace. So the impedance offered by this fellow is 1 by Cs, and R is anyway R. So what will be the V of S by Vi of S? Well, this will be nothing but what will be this? Let's say assuming there's a current flowing here I, so it will be IR, I can say that. And what will be Vi of S is nothing but a drop here plus here. So I can say that I into the impedance here, let me call as a Z. Let me call that impedance as Z. So IZ plus IR. So if I say I can take I common, this will be R by Z plus R, and which ultimately if I replace R by this become 1 by Cs plus R, and I can further drill down. This. So which will be nothing but RCS by 1 plus RCS. And what is this exactly? If you're smart enough and if you've studied Bode plot, I can plot this itself. What it is saying nothing but just for high-end information, I'm saying that it has 1 0 and 1 pole. So if you try to plot this, this is basically a filter. If you try to plot it, initially at origin itself you have a 0, right? So there will be a 0, and then at some point of a pole, maybe we have not covered this, but this is a later part of the control system where you will be studying that. So what will happen is, if you have a, just for information, if you have called as a 0 at origin, 0 basically what happens is 0 give you a rise of 20 dB per decade and pole give you a fall. So what will happen is there will be a rise at some point and there will be a point where you will have a fall. The rise and fall will get cancelled, and this is what will be a filter. So basically I can say that if you look, the lower frequency, this is an omega and this will be a gain plot. So the lower frequency is getting attenuated and higher frequency, as omega is increasing, it is allowing. So basically the low frequency is not allowed. So it is nothing but what? It is an high pass filter, because it is allowing the higher frequency to pass away. Thank you guys.